Okay, now question 6 says, two satellites orbiting the Earth are situated on opposite side of the Earth. Satellite A has a mass of 4,600 kg and satellite B has a mass of 5,300 kg. Satellite A, it is at a height of 28,000 kilometers above the surface of the Earth. So it is at a height of this much, okay, above the surface of the Earth, right? State Newton's law of universal gravitational State Newton's law of universal gravitation in words. It says every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Very important. Just 2 marks. This one you should know off by heart. And then let's see. 6.2 says calculate the magnitude of the gravitational force between Earth and satellite A. Okay, so we want gravitational force. So F it is equal to G m1 m2 divided by r squared. Now m1 is going to be the mass of the Earth. Okay, m1, let m1 be equal to mass of the let m1 equal to the mass of the Earth, and then m2 be equal to the mass of the satellite. And then I'm going to say F it is equal to my G, okay, my constant it is 6.67 times 10 to the power of negative 11. Mass of the Earth is going to be, we know that from the formula sheet, 5.98 times 10 to the power of 24. Mass of the satellite we are given to be, mass of the satellite A, okay, it is 4,600 kg. 4,600 kg. And then I need to divide by what? By the radius. But now the radius, the first one is going to be the radius of the Earth. Okay? Since well, it is at a height above the satellite. If it was here, okay, if it was here, let's say this is satellite, this, and then this is Earth. If it was just moving around the surface of the Earth, well, we're going to just use radius of the Earth as 6.38 times 10 to the power of 6. But now, since well it is at a height, satellite, since well it is at a height, so it's going to be the radius of the Earth plus the height above the ground. Okay, so the height above the ground we're given to be something like how much? 28,000 kilometers. Okay, so 28,000 kilometers. All right, so, but remember we want this to be in meters. Okay, remember we have this in meters, so we want 28,000 kilometers to meters. Okay, remember from kilometers to meters. Okay, let's use this conversion. In 1 kilometer there is 1,000 meters. Okay, now we have 28,000 kilometers. Then we want to know how many x meters do we have. So it's going to be x multiplied by 1, it is x, and then 28,000 multiplied by 1,000, 28,000 multiplied by 1,000, it's going to be equal to 28 times 10 to the power of 6 meters, which is 28 times 10 to the power of 6 meters. And then don't forget, we need to square all that. Okay, we need to square all that. Okay, yes. So, and then we get our F to be something like 1552.29, sorry, newtons. So that is that. Explain the term weightless. Okay, the term weightless is the sensational experience when all contact forces are removed. So it means now there's no, remember weight. Remember, weight, it is mass times gravitational acceleration. So when something it is weightless, it is now it is the sensation experienced when all contact forces are removed. So there will be no contact forces, meaning the masses will be apart from each other. So they will be weightless. They're off like that. Okay, so yes, a rare definition. Then 6.4 says, what distance above the Earth? What distance above the Earth? Oh, so what distance above the Earth's surface should satellite B be to experience the same force towards the Earth as satellite A? So, so the question is, what distance above the Earth should satellite B be to experience the same force towards the Earth as the satellite A? Now, they want to know if the distance here between I can remember we had A here, and then we had the Earth, we had satellite B. So this one was at a height of 226,000 kilometers. So we want to know this one should be at the distance of how much, such that the force here experienced between E and B is the same as the force experienced between A and B. So we want the force to be the same, okay? So if you want the force to be the same, then we will need to show, okay? We will need to show that. How can you show that? How can you show that? Okay. So you can say, okay, for us to have the same force, okay, you can explain using calculations, okay? By the way, remember the mass of A, the mass of A was 4,600. And then the mass of this one was 5,300. Okay? Now, for this one to experience the same force of this one, we need now, you can say, for the force between A and E to be equal to the force, okay, between B and F. So for those to be equal, we need to see, basically, we need this to be equal. So what should be the distance so that these, okay, okay, let me ask it like this. The distance of B from the Earth, should it be greater than this one or less than this one so that now it is the same force? So we're going to use calculation. We're going to say F it is equal to G M1 M2 by R2, where M1 is the mass of the Earth and then M2 is the mass of satellite B. So we wanted the force to be the same. And remember, the force that we calculated was 1,552.29. G, it is the gravitational constant, okay, which is 6.67 times 10 to the power of negative 11. Mass, it is 6.38 times 5.98, so times 10 to the power of 24. And then the mass of this one, it is 5,300. When it comes to the radius now, okay, it's going to be radius of the Earth plus the radius that you are looking for, the distance that you are looking for, the distance that you are looking for, D. Okay, so let's say the radius of the Earth, it is 6.38 times 10 to the power of 6 plus D squared. And then when you do your mathematics, let me go through this mathematics with you. We're gonna multiply this to the other side. It's gonna be 155 2.29 multiplied by 6.38 times 10 to the power of 6 plus D all squared, remember. And then I'm going to write this as it is here. Okay. Okay. Okay, and then what I'm gonna do, I'm gonna divide everything by this value. So I'm gonna divide both sides by 155.229. Okay, and then remember this is squared, and then I'm gonna take the square root. When I take the square root, I will have 6.38 times 10 to the power of 6 plus d, because the square root will remove this part. All right. And then d will be equal to whatever that you get here. And then, okay, let me just punch that on my calculator quickly. You get something like 3.69 times 10 to the power of 7. And then for me to find d, I'm going to need 3.69, okay, 3.69 times 10 to the power of 7 minus 6.38 times 10 to the power of 6. And then I get a distance of 3.05 times 10 to the power of 7 meters, which is the same as 305.2000 meters. So now the question is, the distance should be how? Check, the distance here, it is 3.05 times 10 to the power of 7, but the distance here was how much? 28 times 10 to the power of 6. So now the answer is the distance thereof should be greater. Okay, the distance should be greater. All right, yes, guys. So yeah, that's that. That's that for that question thereof. That's that. And then yes.